Okay, so in the last video, we added some controls to limit how far this could rotate left and right. Now we want to limit how much it can rotate forward and back. So there's really no need to reinvent the wheel. We can just use the same logic over again. So just going to copy this one to this one, copy this one to this one, add the extra parenthesis in the front. And just as we're changing the z vector here, and therefore we have to check the z rotation, here we're changing the x vector, so we have to check the x rotation. Now in testing this, I did notice that this rotation vertically is not enough to make it roll for some reason. And as you notice, this was barely enough to make it roll horizontally. So let's tweak this a little bit and see what kind of trouble we can get into. So we said these had to be consecutive, and this one has to be the bigger number. So let's try bumping this up to 11, and we'll have this one be at 10. Likewise, this one and this one are consecutive, and this is the smaller number. So let's make this like 348, and therefore this should be 349. Let's see how that works. So let's tilt it, and there we go, just enough to make it roll. But problem is it doesn't want to rotate forward and backward again, because now it's hard to see without having these values be dropped into the debug log. But basically, when you're changing one vector, you're also changing the other. So when you're rotating on one axis, you're actually changing the other as well. So we need to bring this in line with it. So just as this is 48 and 49, you would also want this to be 48 and 49. So you have parity, basically the same amount of rotation. And this is 8, so this would be the lower of the two, so 10, and then 9 was changed to 11. Now let's try this again. So forward, back, left, right, and there we go. Now we're rotating pretty good. So basically, we created a dead zone. We let one axis roll greater than what the other one could roll, and so it created a dead zone where really only one direction worked. So, okay, so we added the controls there. So now that we have the basic control into place, let's make sure that it's sufficient for gameplay, and let's start adding some additional partitions to actually make a little bit of a maze to navigate around. So it's not meant to be complex, just again more kind of proof of concept. So I'm just going to copy one of our cubes here. And now we're just going to change the size. So scale the X. And now we'll copy this one, slide it in, also shrink it. In this case, it's the Z we want to shrink. Oops. I need to take that back. It is the X because the object's rotated. So got to keep that in mind when you rotate an object. You might not be changing. You might not have to change the axis that you think, because going towards deeper away from the player, okay, that's the Z-axis, and yet Z was wrong. I had to change X to change that dimension, and that's because this object's been rotated. So keep that in mind. There's a difference between the coordinates of the object, the x, y, and z of the object, and the x, y, and z of the environment. So basically the difference between the local object and the world environment. So good mistake because it's a teachable moment. And let's just copy this one, paste it, and we'll just slide this over. Okay, doesn't have to be pretty, we just want to check the rotation, the maneuverability. Okay. So there we go. Okay. So actually I just noticed the reason why it's rolling, it's ever so slightly clipping this when it's dropping. Well, it still must be clipping it. There we go. Here we go. It still feels like there's a little bit of a dead zone in there when you're at the extremes. So again, we can get into that with a fine tuning, where maybe we can do a little bit of an autocorrect that when you hit the limit, maybe it bounces back just a little bit so you don't have that dead zone, but it's certainly usable, and this is sufficient to navigate because we just did a bunch of corners and it was fine. So now what we'll do is we'll just add another wall just to make it a little bit more complicated. And we'll extend this. Okay. And we'll do this one more time. And it's important to note, when you're copying it as a child, it pastes the child, but just make sure it's actually a child or else it's not going to rotate. So make sure that all these walls, all these partitions are indeed children. There we go. So let's add the goal, and we're going to use a particle system. So game object particle system. And this isn't really meant to be a particle system tutorial, so I'm going to just go through this quickly, but I am going to point one thing out. Because I had no idea why this was happening when it first happened to me. So here's our particle system. Looks normal, the default particle system. Watch what happens when you make it a child to the platform. It goes absolutely bonkers. So what you want to do is you want to change scaling mode. Normally you don't have to mess with this, but in this case you have to turn to either hierarchy or shape. Let's turn it to shape, and now we can go about this like normal. As far as changing color, changing size, increasing the emission rate, or excuse me, increasing the max emissions, max particles, so increase the emission rate, and the type of sculpting you have to do to make this look the way you want it to look. And with this, it's entirely what you're looking for, whatever look you're trying to create. Now let's go ahead and add a rigid body. So physics and rigid body, we're going to get rid of gravity. And the reason why there's a rigid body is because odd things happen with collisions without rigid bodies. I haven't quite determined why, but put the rigid body there, it won't hurt anything. So physics, and we'll do a sphere collider. And we'll make that a trigger, and we'll edit, we'll shrink it, and we will lower it a bit, so we want Y. Interesting. Alright, so y is actually moving along the z-axis. So like I was saying about, you have to be careful with local versus absolute. So if we want to lower it, we actually want to lower the change the z, it looks like. There we go. So again, good demonstration of the difference between the local vectors and the vectors of the world environment. And we'll just shrink that a little bit more now. That should do it. As far as moving around, we won't do the collision yet. Let's just make sure that's working as intended. We're going to take tilt, drag and drop it onto this. And I've already checked the script. There's nothing in here that explicitly refers to the name of the object it's attached to, so shouldn't have any kind of negative impact. So let's give that a run. So there's the exit, and as you tilt, it tilts. Perfect. Okay, so now we're just going to add the collision. So right click, create, C#, and we'll just call this ball. Go and click on the sphere, put ball on the sphere, the ball script that is, already has a collider, already has the rigid body. So now we just need to open that script up. And outside of start, outside of update, void, oops, on, trigger, enter. Collider, other. That's a predefined routine, so it's case sensitive. OTE must be capitalized, C must be capitalized, or it will not work. So we're just going to check to see if other dot name, so the name of the other object that's being collided with. So if the name of the other object, right now it's particle system, let's change that to goal. So if name is equal to goal, then a couple things. A, destroy game object. So what does destroy game object do? Destroy game object does just that. It destroys the object that the script is attached to. The script is attached to the sphere, and therefore the sphere will be destroyed when it collides with an object named goal. And in the debug log, we're just going to put in you win. So I always recommend putting in a debug statement whenever you're adding collisions, because there's so many things that can go wrong, and it's not because they're glitchy or buggy, but like I said, if you accidentally capitalize a letter that you're not supposed to, this doesn't work. Maybe the object isn't actually a trigger, this won't work. Maybe you put in the wrong name of the object, so it's not glitchy, but it's easy to make a mistake. So you always want to make sure that you're doing a very simple statement to check to make sure this is working. And right now it doesn't like that, and the question in it is why? Because I don't have a semicolon. All right, that should do it. So roll, 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 bam. Now what you can do, if you don't want it to disappear right away, that okay, they won, but you want it to travel a little bit more, you can do something like 0.2f. So what you've done is, by doing 0.2f, this is an argument that doesn't have to be here, and that is, it's game object, comma, and then how many seconds you want to wait before it actually destroys. The f is there because this is a decimal. So watch the difference. See, it disappeared really when it was solid over it. So this condition and this condition were met, but to make it a little visually more appealing, you make a slight delay. So they had already won, but you let it actually fully roll onto the goal before you destroy the object. So it's little details like that that people do pick up on. So that's about it for this lesson. So there you go. You have the basics. You have the banes that you can make. You have the goal. So if you guys want anything else, just let me know.